Hi everybody, Mrs. Kroll here. In this video, I'm going to go through the 7.2 Verifying Solutions to Differential Equation worksheets. Alright, so the first one, which of the following is a solution to the differential equation here? So there's my template. I'm trying to fit everything into with the initial condition 0, negative natural log of 4. So this initial condition right here, all it's saying is that this is true on one of these solutions. And so if you go through all of them and you plug 0 in for x, you would see that you get negative natural log of 4 for the y. And that's true for a, b, c. Negative e to the 0 power would be negative 1 plus 5. That's going to work there too. And then coming down here to d, 0, yep, that would work in that one, except for E is the only one that's not going to give you that initial condition, so we can cross that one out right away. All right, and then we're just going to go ahead and we're just going to look to see which one of these is the solution to this differential equation. So we got to start off by taking the derivative. So the derivative of the first one is going to end up being derivative of negative x is negative 1. And the derivative of the natural log of 4, well, that's just a number, so that is going to be 0. So here we're saying the derivative, so negative 1 is equal to e to the y. We're going to plug in all of this. Negative x minus natural log of 4 plus x. Well, in this case, the negative x and the negative positive x, those are going to cancel each other out, so that we'll have negative 1. Let's erase this y prime part. Negative 1 equals these x's cancel e to the negative natural log of 4. Now, a log property means that we can bring any of these numbers out in front and bring them up to be the exponent. So negative 1 e to the natural log of 4 to the negative first power. And then the natural log and the e are inverses of each other, so those will cancel out. So I'll have negative 1 equals 4 to the negative first power. Now, that is not true, so we know that this is not going to be a solution. Okay, well, let's try B. In B, we're going to do the same thing. We're going to take the derivative, and the derivative here, derivative of x is 1. Derivative of the natural log of 4 is going to be 0. And we're going to plug that in. We want the derivative to be equal to, so 1 equals e to the y, x minus natural log of 4 plus x. So I'll have 1 equal to e to the 2x minus 4, natural log of 4. So how are we going to simplify this? Well, a property of exponents, if it's subtraction, changes to division. So 1 over e to the 2x divided by e to the natural log of 4. Now we know e and natural log of are inverses of each other, so those are going to cancel out, so that this will give me 1 equals e to the 2x over 4, which is not equal to 1, so this is going to be crossed off as well. Okay, let's try C. When we go C, okay, we want the derivative of C. So the derivative of C is going to end up being, derivative of natural log is u prime over u. So the negative stays on the outside. And the derivative of u, the inside piece, is going to be negative e to the x over u, the whole thing, negative e to the x plus 5. So my derivative that I have, the negative times the negative in the numerator is going to cancel out. So e to the x over negative e to the x plus 5. And I want that to be equal to e to the y. Okay, this whole thing plus x. Now, subtraction turns into division. So this negative natural log is in front. That means it's going to be in the denominator of my division, and this x is positive, so that's going to be in the numerator of this division. So this is going to be e to the x over negative e to the x plus 5, and that's going to equal e to the x over e to the natural log of negative e to the x plus 5. And e and natural log, those are inverses of each other. They are going to cancel each other out, leaving me with just in the denominator this negative e to the x plus 5, which is what I want it to be. So this is going to be a true statement, and C will be the solution to my differential equation. All right, let's try number 2 here. Again, we can run through with this initial condition that we have when x is 0, y is 5, and we can figure out which ones are going to fit there. The tangent of 0 is y over x, which is going to be 0 over 1. So the tangent of 0 is 0. So e to the 0 is 1 plus 4. That works. This one's going to be 1 plus 5, that is not going to work. Here, e to the 0 is going to be 1 times 5. That would work. It would work over here as well. And 0 plus, tangent of 0 is 0 plus 5, e to the 0. It would also work there. So the only one we can cross off is B. Now we're going to go ahead and we're going to use this differential equation to figure out which one's going to end up matching in there. So we got to start by taking the derivatives. So starting off with A, we're going to go e to itself, for my derivative, I should say, times the derivative of the inside, which is going to be secant squared, plus 4. The derivative of plus 4 is going to be gone. So we're going to look, does that match up with this, which is going to be y times secant squared x. And that's not true because I have the secant squared here like this one, but this is not the y that we originally started with. It had a plus 4 on, so this one's going to not be true. Okay, so let's move on to C. My derivative is going to be 5. Derivative of e to the x is itself times the derivative of the exponent, which is going to be secant squared x. Okay, again, I have the secant squared x here in this derivative. Oh, and this is the original that was here, so this is going to be true. So C should be my answer. Okay, 3 is, which of the following is a solution to the differential equation? Y double prime minus 4y equals 0. So this is the template we're trying to fit everything into. But this isn't multiple choice. Now it's going to be circle all that apply. So let's get started taking some derivatives. So a y prime is going to be 2e to the 2x. And y double prime is going to be 4e to the 2x. And I'm looking to see if y double prime minus 4y is going to equal 0. So y double prime minus 4 times this, would that equal 0? And yes, that's true. Now let's try B. So y prime is going to be 4e to the 2x. Y double prime is going to be 8e to the 2x. So if I look at this and I multiply the take my second derivative, 8e to the 2x, minus 4 of these. That would also be 0, so that is also true. Okay, let's move on to C. First derivative is going to end up being derivative of sine is cosine of 2x times the derivative of the inside, which is going to be 2. And then my second derivative is going to end up being negative 4 sine of 2x. Now, if I take the second derivative and I subtract 4 of these, those will not cancel each other out, so that's not going to work. All right, let's try D. So my first derivative of cosine is going to be negative sine, derivative of the inside, so negative 2 sine of 2x. And then second derivative of cosine is, or derivative of sine is cosine. So that's going to be negative 4. Okay, and the signs are the same on this one as well. So if I take my second derivative, negative 4 cosine of 2x, and I subtract 4 of these, we're going to keep it being negative, so they will not cancel each other out. So D does not work.